Consider a binary code that consists of only 4 valid code words as given below: 00000, 01011, 10101 and 11110. Let the minimum Hamming distance of the code be P and the maximum number of erroneous bits that can be corrected by the code be Q. Then the values of P and Q are, and we have been given 4 options. So this is a straightforward question coming from Hamming codes, that's coming from number systems topic in digital logic. So if you don't know Hamming codes and error correction etc., please refer to the video lectures to understand more about that. So for this question I will show you how to do it. So these are the 4 codes given that I have written here. These are the 4 valid codes in our system here. Now the Hamming distance between any 2 valid code will be the number of bits we need to change in order to change it from 1 to 2. So 00000 and 01011, if you consider the number of bits I need to change in this to make it this will be, so here it is 0, here it is 0, I'll keep it just like that. Here it is 0 and 1, so 0 I need to change to 1, it will add 1, 0 and 0 is same, 1 I will need to change to 1 and 0 I will need to change to 1 and this 0 I will need to change to 1. Meaning I need to make changes in 3 bits in order to convert this code to this code. Now that is the Hamming distance between these 2 codes. Now I have written down all the 4 codes and I have drawn a graph here showing the Hamming distance between each of the codes. Okay. Now these are all numbers in the code. So the total Hamming distance for this entire code will be the minimum distance between any 2 valid numbers in the code. So if you see, the distances are 3 and 4 whenever we take 2 pairs from this. So the minimum would be 3 here. So the Hamming distance of the entire code will be given as 3, which means that P equal to 3. Now we have found out P. Now we need to calculate the maximum number of erroneous bits that can be corrected by a code. Now if the Hamming distance of a code is P, then the number of bits that can be corrected will be P minus 1 by 2. Now that I can apply directly here. So Hamming distance is 3, 3 minus 1 by 2 will be 1. So the value of Q for this question will be 1. We can only do correction for 1 bit. So the option will be P equal to 3 and Q equal to 1. Now how I got this formula, please refer to the video lectures to understand that more, but I will give a rough explanation here as well. So consider the code 00000. If I need to change it to code 01011, I need to make 3 bit changes. Now suppose that we know there will only be 1 bit errors at maximum. So there can be 0 bit errors in which we got a valid code only, there is no error, or at maximum 1 bit error. Let us say there won't be any 2 bit error in this. Then we can easily do error correction, because consider this number 00000. Let us suppose I make a 1 bit change here in this bit, and let us say it becomes 01000. So if I calculate the distance of this code with each of the numbers in our code given, then if you will see that only to 00000 the distance will be 1, and to all the other numbers the distance will be greater than or equal to 2, since it was only a 1 bit change. So if we know that it is a 1 bit error, we can definitely find out from which number we arrived at the erroneous number. So only for 1 bit I can do error correction just like that. Now suppose there can be 2 bit errors as well. Let us say A and C are 2 valid numbers in our code. With 1 bit I can say, let us say I can get x1 the number, and with 2 bit changes let us say I can get x2, and with 3 bit changes let us say I can get another valid number C here. So on changing A to C, if there are 2 bit errors, then from A I can get x2 also using 2 bit changes. From C I can get x2 using just 1 bit changes. So if I get an erroneous number like x2, I will see that using 1 bit change I can get C, using 2 bit change I can get A. So I can't say for sure which one it would be, whether it came from A or C, because we are assuming there can be a maximum of 2 bit errors. So if there can be 2 bit errors, we can't do error correction like this. There will be multiple numbers to which that erroneous number can match. So in this system we can only do 1 bit error correction. That's what given here, and A is the right answer.